So there are all sorts of, so I just wanted to kind of, we took the first hour essentially to kind of walk you into that. So I apologize for that taking quite as long as it did. That's why I always look at this and I think it's going to be a very short class, and apparently it's not as short as I had thought it would be. But now let's do a few things. There's a couple exercises here just to warm you up for your lab. And you guys you didn't see a license in Cytoscape. We may have to check that one up. And remember that some places, even some commercial places, don't actually license correctly, which is both dangerous for them and dangerous for you. More dangerous for you, actually. So, okay, Sage Math. If you go to Sage Math, I think we've been here already. There's all sorts of stuff here for you to look at. Take a look at it. It's free, open source mathematics system licensed under the GPL. That's where you ought to have your license. In the first sentence, when you're describing your system, you should have your license. It is licensed under. That way people know exactly what they can use it for and can't use it for. But here's the front page. There's all sorts of stuff here. Your downloads. You can download Sage for Windows. You can take a tour. Whatever you want. So this is an open source alternative to Maple and Math and Mathematica. We're going to do something. We're going to go to Sage Math Cell, which is an online implementation of Sage. And we can type in some stuff here. So I think I asked for the 450th factorial, or the factorial of 450. So Sage is fast. We come in here, we click evaluate 1 and 2 and 3, and there's the answer. That is the 450 factorial. And as you might be beginning to expect by now, you can use arbitrarily or at least very large numbers in Sage Math. In fact, they can do some things symbolically. That isn't symbolic. That's numbers. We can also come in here and we can do a few more commands. Let's look at the 12th root of this equation. Why, you might ask, before we go out there. Let's take a quick look here. Well, Homer Simpson, you know Fermat's last theorem, right? So Homer, always the mathematical mind of the Simpsons, was kind of doodling one day in one of his things, and he came up with this little equation. 3,987 to the 12th plus 4,365 to the 12th. Angry LGPL, okay. Angry math noises, yeah. 4365 to the 12th equals 4472 to the 12th. So we can actually come in here, and because these are big numbers, that's kind of hard to compute sometimes. I can't do it in my head. But we can come over here and we can do something like, right, that's just the numbers raised to the 12th power. The sum of the numbers raised to the 12th power equals this big long number. We can figure out the 12th root of this. If Homer had access to Sage Math, he would be able to, he would have been able to do this. He wouldn't have made this silly little mistake. If we evaluate the 12th root of that, we see that, in fact, it is symbolic. It's 9 times 22, all those numbers raised to the 1/12th power. Well, that's not any good. We don't actually want symbolic math at this point. So we can come in here and we can say, okay, give me the actual number. So the n command, I believe, is the one I need to give me the number. Evaluate this, and this comes out to be almost 4,472 to the 12th. So Homer almost solved Fermat's. Now, of course, this is not really anywhere near it, because if we just do this simple subtraction, 4472 to the 12th, we'll find out that that's actually a pretty big. Right, if we do that, we find out that that's actually a pretty big number still. But yeah, Still a pretty big number. But Homer came close. He had a just miss on Sage. So one of the read this article if you get a chance. By the way, it's a really interesting article, and it talks about why so many comedy writers or cartoonists appear to be failed mathematicians or have a healthy interest in mathematics, because these things do keep showing up if you pay attention in some of our wonderful cultural norms. Okay, one more. Let's see, what else did we want to look at? I guess that was all we wanted to look at there. Morthy, this is a lot of playing around with Sage that Morthy did. Feel free to check that out. He's got all of his stuff there. The other thing that I wanted to point out was this CoCalc. Sage Math, right? Sage is open, right? So you can use Sage Math. You can download it. You can add to it. But you can also come in and you can rent time from them on a Sage Math installation. So, if you want to do collaborative development with your friends, it's just like renting. Like, if I'm understanding the model correctly, it's like an AWS, except that it's an AWS with, Mathematica essentially in it. So you can, you can play around and do that and distribute it to your students. And they have a free and a paid tier. And it's a way to try to make money off of something that's essentially free, offering a service, offering something that you can distribute, offering a way to collaborate, a way to run a classroom, is a value add that very well could end up being a business model that keeps both the company and Sage Math alive for a long, long time. The one bad thing about this was it's not clear that this is they're actively collecting money right now. Oh, here we go. I was going to say, because I couldn't find the pricing, but here we go. Here's the actual pricing. So you can teach a course in CoCalc. All right. So that was our first kind of warm-up exercise, just playing with CoCalc a little bit. The second thing we want to work through is we're going to look at two different Python libraries that kind of work together. So the first one is this Pygame library. And if we go out to here, and you guys are welcome to kind of work through this on your own, or not. But they have this little Pygame tutorial, and it's a really simple Python game. In fact, what we should probably do in CS1 is move away from tkinner and into Pygame. The one thing here that I don't know how much this is kept up. I should probably take a better look at it. But they're saying to use Python 2.7, and I can tell you that Python 2.7 is just not a good thing anymore. But if we're going to work on something, let's say we want to go to our handy-dandy Unix box or Linux box, Ubuntu. Right, so here's our Ubuntu box. I found out that I have to use Python 3, so cool. Thomas did bagels versus cats, apparently. I'll encourage you guys to. You don't have any embedded virusware in there, right? If not, I will encourage everybody to install this. It's a nice. It looks like a nice little game. I'll take a look at it in a few minutes. Maybe if you have it licensed correctly, maybe we'll make this the focus of next semester. Anyway, we want to install Pygame. If you have pip installed, it's pretty easy. Pip install Pygame. I have to use pip 3 because and if you're using WSL, you will as well, because pip will try to install Python 2. We don't actually want Python 2. And why is this taking so long? Did I lose? There we go. Requirement already satisfied because I was playing with this last night. And this just walks you through a really simple bare bones game. Let's see. I can go to code, ls, and we can kind of walk through this if you'd like. Let's see. Maybe I got to go to this instead. Okay, so we can come in here and we can do a So this is kind of the end part of the game, but we can kill this. Come in, let's grab the game. Huh. There we go. All right, so that's a simple game. It's really simple, as we'll see in just a second, in that it doesn't actually do anything. But if we just come in here and run this just sets up a game environment. They go through this in a lot of detail as to what this actually does. But essentially what it does... again, I'm using Python 3. And you can see this little thing here that's going to prove to be problematic later. So we'll get to that in just a minute. But this just flips up a window. So let's look at what we're actually doing. We initialize our game. We generate our screen, right? This is about 400 by 300, I'll believe that. And then we just go into an infinite loop. We look at events, right? Essentially, the only event we're looking for here is the quit. And then this is double buffered. So you draw into a buffer, and then you flip to the other buffer so you can see it. Well, we only have one buffer. We didn't do anything. So that just brings up the little black square. That's kind of explained in endless detail there. We can do something. We can add a little blue square to it. And we can pop that in. Let's see. Okay, so we can pop this little draw in here, and that has to be in the for loop. So let's All right, so we can do that. I'm going to get tired of this in a few minutes, but right, and now this will bring up a little, the same box. Same box, but now we have a little blue square in it, right? And now we can start doing some things like listening to keys and so we can start listening to keys and doing things like changing the color. And down here, right, all we're going to do is, instead of drawing a blue rectangle, we're going to set a color. And if it's blue, we'll draw it in blue. And if it's not blue, we'll draw it in some other color. And then, of course, what we need to do is we need to have a way to change the color from blue to other colors. So we can come in here, we can do another copy, come over, and this is now an event. Right, so this event type is not a quit event type like the first one was. This one is a key down event. And all the key down event is going to do is it's going to change our square between blue and not blue. Right, so the whole idea here is we're just kind of walking through the first couple of examples just to see how we can generate the beginnings of a game. Not nearly as nice as Thomas's bagel. I can bring that up, by the way. Bagels versus cats. I hadn't realized that bagels and cats were mortal enemies, but you know, I'm okay with that. It almost looks like Plants versus Zombies, man. Simple tower defense strategy game. Very cool. Of course, you know, now when we run it again. Hopefully I saved because I wasn't paying that much attention, and I have an error, of course. So apparently I did save, but poorly. I thought that was a mark on my screen. It was a exclamation point or a quotation mark. All right, so now we have another square with another blue box. But now if we hit the space bar, it changes from blue to orange. And if we want, you know, we can come in and all the keys are evaluated in this. I'm not going to walk you through that. I don't think. It's pretty... Let's see. You know, you can look at all of the keys. Dir Pygame will give you all the keys. This lambda function will just pull out all of the keys themselves. Dir Pygame will tell you all about the game. The K underscore will just pull out all of the key bindings, so you can see all the things that are available for you to tie to, and you can tie to the mouse as well. I think the last thing, well, second to the last thing, we can also tie to, for example, what did we tie to this time? So we also tied to the up, down, left, and right keys, so the arrow keys on the keyboard, and we're going to use that to move. So we can come into here, right? And this is just what they had here. So we tied into the up, down, left, and right keys. So we can move 3 places across the board every time. We should still be able to color our game. So let's see, we should be able to do a Python 3 game. And that's going to come up. It's going to give us our little box. We can change the color. Let's see, I'm going to go right. That's not exactly what we want. We would kind of like to, I mean, maybe it's what we want. If we want to do a drawing game, right, we can draw here. But maybe we want to just move our box around. If that's the case, then we have to get rid of it. And I'm kind of surprised. I thought this, maybe my system is slower than last night when I hit that button, it just tore across the screen. So we probably actually want to slow it down a little bit. Anyway, so we can do, it's not so bad. The system is slower when I'm actually recording than when I'm just running. So I think the final thing we want to do is we're just going to add a little bit more code into here to erase as we go along. And that is the screen fill command. Right, so that will just fill up the entire screen with zeros before we draw our rectangle. I think is where I have to put that. I think that's where I want it. And then we can also tell it how fast we want to run. So we can come down to the very end and do a clock dot tick 60. So that will only do 60 frames a second. And I think that's all that there is to it. But this becomes a nice little way to kind of build up a game. And you can make it as arbitrarily. You can, oops. Yeah, apparently you actually need to define the clock as well. And that was crossing my mind as I actually did that. So, anyway, I should have listened to myself. All right, so this is just a simple little game. It doesn't do much for us, but it does allow us to kind of get the feel for moving around and changing colors and how we can bind to keys. And I think I'm going to look into maybe using this for CS1, at least evaluate it. All right, so that's our warm-up 1. You know, again, it's just simple code, but this is, if you're going to do something in scientific computation, what you want is you want a physics engine, or you want some computations behind this, and then you want to tie it to a cool narrative or visual effect, like a tower defense game where cats eat bagels, to kind of give it some realism. So the next thing we're going to do, and it's the last thing we're going to do in class today, is we're going to take a look at something else. I think it's that and the last thing. Yeah. So it turns out that, and this is where we're starting to run into an issue, by the way. It turns out that there are some free versions of games such as Angry Birds, or at least some open source implementations of some Angry Birds kind of things. So if we go to this link, we can go in, and Esteban has his Angry Birds, and it looks like development on this stopped back in 2017, which was good up until last semester, or last time I taught this. It uses Pygame for the visual interface, the thing we want to connect to. And then behind the scenes, it uses this simplified physics library called PyMonk. And I think we looked at that earlier, right? So you can use pip to install both of these. If you're using Python 3 on the WSL, then you'll have to use pip 3. But you can use pip 3 to install both of these. And then once you do, you can go in and run it by running, well, the main. If you're on a Mac, you're going to need Python W instead of Python because of the way the bindings of Pygame work with the Mac. Right? For some reason, Python W does a windowless, or maybe it's a window. Anyway, Python W allows you to actually use the graphical user interface. So we're gonna take a look at that. We're gonna take a look at some of the source code. Here's some of. I shouldn't have put those escapes before the quotes. I think we're nearing end of life on this example, at least the way it's formulated now. So if anybody has a hankering to update this to the current versions of things, please go through and do that. It would really help us out. We need to use Python 3.6 or above, which is good. We're at 3.8 or something like that at this point. The problem is that PyMonk, the physics library, just did a major refactoring in the last couple of months. Certainly since I think it was November. And they went from 5.7 to 6.0. And Angry Birds does not, they changed the API considerably. When you update a major revision number, that's not all that unusual. I discourage it among you guys because, as soon as you change it, things like Angry Birds that somebody maybe doesn't use that often, all of a sudden becomes obsolete when you update your libraries. But we need to downgrade PyMonk to 5.7. So this command, if you're having issues, will downgrade PyMonk to 5.7, which will get rid of a partial issue for us. And then the other thing that I ran into was that on my system, on using WSL, and I didn't try it on my Mac, but using WSL, I had to disable music because WSL couldn't access the music card, and it got messed up. So disabling the music card, I'm going to just kind of show you where that is. I'll go down into Angry Birds Python, and you can see that git remote -v. This is Estefan's Angry Birds, and we can do a git diff. And it turns out that the only thing you have to do is kind of comment out these lines down in the load music, area. And you should be able to do that fairly simply. And when you do, and you get PyMonk downgraded to 5.7, which is the last version before the rewrite, you should be able to come in here and do something like Python 3. Sorry, go down to the source. You should be able to do something like Python 3 main.py. And it should bring up, if everything is cool, and it is, our Angry Birds. And you can play. But you shouldn't just play. Yeah, this is a lot slower than it was last night. Okay, but you shouldn't just play. Let's kind of look at a few things. You should play, though. It's fun, and it's fun to do it here. What I want to talk about first is the last bullet. And I think this refers to the original Angry Birds game. But here's the key, is that there are actually physics in this game. And more than that, you can use tools to measure the physics in this game. So this guy spent probably far too much time going through, of course he did get an article out of it, going through and tracking the video, doing a video analysis using some video analysis tools. To go out, old link, I should have checked that first. To go out and measure, the position of the birds on the page so they could calculate constants like the gravity constant, the acceleration constant for the slingshot. So that it's interesting. He can go through and he can use the same things that we apply in our college and high school physics to derive the same principles of, the physical system, because under the covers, these games are actually using a physics engine. Okay, so I just find that really interesting. That's why I like this particular example, because if we actually play the game, what we find out is that our birds actually do have an arc, right? We send them up, they travel in a parabola, and they come back down. And this is because there's a physics subsystem underneath here that's doing these calculations to apply the gravity to them, that's doing the calculations about when things actually collide, right? And then allow us to take some action based on that. And they've allowed us to do a few things, like if you press the W key here, you actually put a wall into the system, right? So things can't bounce off the back. Do some trick shots. W again gets rid of it, so we can shoot past the wall. Right? And then there's also the ability to do space or normal gravity. So S turns on space gravity, and you'll see that just really is almost no gravity at all. And if we go back to normal, we'll be back to our nice little parabola. I imagine the space gravity will eventually give us a parabola because it's still in there, but it just isn't very much. All right, so let's take a little look at that. Let's see, Pygame works well for collision, but it doesn't have a lot of built-in physics functions. Windowed projector a bit wider, that might make the inner part bigger. Well, that didn't work. I can probably do it on this, maybe. Is that what we're talking about? Yeah, Pygame is a really simple one. I can tell you that some of the other ones have a lot more... no, it didn't work. Have a lot more functions. Certainly the surgical simulator had a lot more stuff, and the collisions are actually the hard part of a lot of that, is figuring out when two things collide and the direction and the rebound. The text is really fuzzy. I don't know. All right. I think what we'll do is let's just take a look here. I'm going to bring up the... I'm just going to take a little bit of a look here at this. Let's make this our window. That should get us less fuzzy, I hope. There we go. Okay. Is this any better? As of now? Okay. Sorry. So let's take a quick look at this. So PyMonk is a very simple physics engine. But what we want to look at is what part of this is graphics versus what part of this is actually the physics engine. Here is our PyMonk. So here's our import of the physics system. What we're going to find out is that all of this is just loading images, drawing things, right? All of this is involved with setting up the game UI. This is the physics. And the only things we're actually specifying is we're specifying space gravity, which is 0, 0, minus 700. Let's see what happens when we make that minus 700 as well. Right? So if we do that and now we run Okay, so now we have a minus 700. Look at those buildings. They're being torn this way. So it's not, so we can have a gravity or an attraction in both the X and the Y direction. So it's actually, there is actually a way to do this. So that's not a gravity, but a wind function more. Although that's kind of a wind function, right? If it's acting on you and it's pushing that way. So we can actually set up like a wind kind of in there. We could also put in something to slow us down as we go forward to do air resistance absent the actual wind. But you can see that, so that actually makes a big difference. We can have wind or attraction in the XY direction as well as in the X direction as well as in the Y direction. Going back to our right, we probably don't want it that high. We'll never be able to hit those rotten pigs. Okay, so basically that's all this. This has a very limited behavior right now in terms of the physics that are required here. But we can now search through and we can look for all the places where we use space. And what we do with space is we add, for example, lines. So we can look at collisions. These are places where we're going to have collisions, and we can set up different collision types. This apparently is the floor. We can add and remove pigs, add and remove birds, add and remove columns, add and remove beams. And then we have this thing called solvers. And what the solvers do is, given a collision between, this one's between a pig and a bird, we can figure out what we want to do in it. So we're removing, for every pig that's affected, we want to remove 20 life from them. And then if they get destroyed, we want to remove them from the system. Here's the collision between the bird and the wood. Here's the collision between the pig and the wood. Again, the pig loses 20. And here we're adding our collision handlers to our space, right? So we now have these solvers that tell us that this is what we do when we have a collision, and here's where we put in the collision handlers so that we call our solver when there's actually a collision. So the physics is going to tell us when there's a collision. the physics is going to tell us what the next position of everybody is. And that's really the only part of the physics we actually need. We add some lines in there. We have something to change the gravity when we hit the S key, right? This is the space gravity. Instead of minus 700, it's now minus 10. Change it back to 700 on the N key. And that's pretty much, right? This sets up a bird in the space at its initial angle and velocity. All right, so we're just adding things into the space, and then this call here actually applies all of the physics that we've set up. It takes all of the actors and their current velocities and angles and our spatial constants like gravity, and tells us what the next position of everything is. And that's basically all we need in the physics department. We do a lot of setup. We add a lot of things in there to set the initial state. And then after that, state just follows every time we call this space.step function. And that's really pretty much it. All right, so let me see, what else was I supposed to talk about on that slide? Okay, and we can set this up. Right now, I think we are in a vacuum. I don't think we have any. I don't think we have any retardation of the birds as it is. You can set that up. How will it play on the moon? Well, we have a minus 10 gravity right now. The moon would be about 1/6. So if it's normally minus 700, it would be like 700 divided by 6. So what? 1 and 2/3, or 1 and 1. 1.2 or something, 120 or something like that. 120 plus or minus. All right, and that's all I have for you today. Your lab is going to go in. Take a look at this example. It's a fun example. It's fun to play with. It's fun to figure out where the parameters are. It's fun to add air resistance. I did that in a previous semester. So play with that. The lab will be on using, I think it's networks is what we concentrate on for that. But that's another piece of scientific software. It allows you to solve graphs and find clicks and things. And we'll use that in the context of a word problem. All right, any questions? If not, we are, pretty much at the end of this lecture. So I don't know why that got small all of a sudden. Oh, because I want to do this. It's getting too hard. There we go. Wanted to do that. All right, so that's all I have for you. What are some of my favorite games? So I actually like the puzzle games. So there's one that I've been playing where you're given the number of filled in spaces in the rows and column of a matrix, and you have to construct the matrix from it. So what is that called? I don't know, something picture. In the end, you get a picture out. Then again, I also played. I was a big fan of World of Warcraft for a long time. Quake 3 is cool. Yep. Unfortunately, ever since I started teaching CS1 and this course and operating systems, my Arcos, my time for playing games is a little bit shortened. Destiny was a big one. That was the last one that I played seriously for a while. Any other questions? All right. Please, again, we need to have projects. So if you're having any problems, please contact me. we can help you out. We can you know, that's our goal, is to make you guys, give you guys some good projects and get you working. So, you know, please get that in. Please sign up. All right, we'll see you guys later.